Hello friends, we all already know that the cardiac disease is the major cause of death in all over the world. When we are thinking about the cardiac protection or the precautions to prevent the cardiac disease, always we talking about the cholesterol and triglycerides. In the cholesterol, we know two terms: HDL, high density lipoprotein, and the LDL, low density lipoprotein. We all know that HDL is good cholesterol and LDL is the bad cholesterol. And we know that this LDL will cause the atherosclerosis or the block in the blood vessel. But we are very rarely going to the deep or the clear mechanism of this atherosclerotic block happening in the blood vessel. Atherosclerosis is an inflammatory disorder because there is one inflammation happening in the blood vessel. That inflammation leads to the block in the blood vessel. So not only this LDL is causing the atherosclerosis, same way this inflammatory reaction also the major factor that leads to the formation of this block in the blood vessel. So how this inflammation happening? If you go through this topic, you can understand that the real killer is the oxidized LDL. LDL also not that much dangerous. If this LDL is oxidized LDL form, this oxidized LDL form creating the inflammation in the blood vessel, and this leads to the atherosclerotic plaque and the block in the blood vessel. So today we are discussing about this real killer, oxidized LDL. Welcome to the another chapter of 1 Degree Change, a continuous learning program for the pharmacist. We all know that this HDL, this cholesterol in the body, this fat molecule is attached to the specific protein called the lipoprotein. And there is 2 or 3 types of lipoproteins are there: HDL, high density lipoprotein, LDL, low density lipoprotein, and very low density lipoprotein, VLDL. And when all this cholesterol, this fat molecule is traveling all over the body through the blood vessel by attaching to this type of lipoprotein. This LDL is entering to or trapped to the subendothelial space. Subendothelial space is the space in between 2 layers of the inner lining of blood vessel. And once this LDL is trapped to the subendothelial space, if any free radical is present in this subendothelial space, it will oxidize this LDL. This LDL is very high tendency to oxidize very fastly, and all of you know that free radical is the reactive oxygen species. There is 1 electron is less, so they have the tendency to attract the electron for the surrounding cells for the stability. Once this form as the oxidized LDL, this particle size will increase and it will not go back to the blood vessel through the subendothelial space. Once it is trapped inside the subendothelial space, body will try to eliminate this particle. For that, body will initiate the inflammatory process. So it will attract macrophages, leukotrienes, lot of inflammatory molecules, and this all will attack this oxidized LDL, and this inflammatory reaction will happen inside the subendothelial space, and this will trigger the chain reaction, and it will attract the lot of other inflammatory molecules also. And this chain reaction will leads to the plaque formation, and slowly it will increase, and it will leads to the thickening of artery and leads to the atherosclerotic block. Coming video is clearly explaining about the formation of atherosclerotic plaque and the role of oxidized LDL to form the atherosclerotic plaque in the arteries.
This is a section of an artery showing endothelial lining and internal elastic lamina and underlying smooth muscle cells. The bloodstream maintains erythrocytes, leukocytes, platelets, and lipoproteins contact with arterial wall. This is the basic structure of LDL and HDL particles. As the ratio of LDL and HDL particles increases, there will be a high risk of atherosclerosis. The LDL particles may bind to the LDL receptors on the surface of the endothelial cells. The receptor LDL complexes is then internalized by endocytosis. Plasma LDL concentrations may exceed the regulated endocytic capacity of the cells. LDL crosses the endothelial barrier and is then trapped in the subendothelial space. The trapped subendothelial cells where they are susceptible for the oxidative stress. The oxygen-free radicals including superoxide anion are released from the endothelial cells and macrophages. Monocyte recruitment plays an important role in the development of atherosclerosis. Preferential recruitment is observed at the site of disturbed flow such as bifurcation. Endothelial cells express various adhesion molecules including VCAM1 and P-selectin. Monocyte attachment to the vessel wall is initiated by P-selectin on endothelial cell, binding to PSGL1 on the monocyte. This initiates rolling, which acts to prolong the contact of monocyte with arterial wall. Monocyte adhesion arrest results when alpha-1 beta-1 integrin and the VCAM1 receptor on the monocyte is activated by rest of chemokines. MCP1 binds to its receptor CCL2 and signals for monocyte transmigration through the endothelium into the vessel wall. Monocyte differentiates into macrophages under the influence of macrophage CSF. Oxidized LDL is then taken up unregulated fashion by macrophage scavenger receptor, which leads to intracellular accumulation of cholesterol and forms foam cell formation. Macrophages are also involved in T cell activation. Activated T cells in turn secretes TNF-alpha and INF-gamma, which amplifies the inflammatory response. Macrophages, foam cells, and endothelial cells continues to release cytokines, activating monocytes and T lymphocytes. Endothelial cells express adhesion molecules such as VCAM1 and P-selectin as well as tissue factor and CD40 ligand. CRP is produced by liver in response to that of IL-6. IL-6 plays an important role in the inflammation and activation of adhesion molecules. Thus, the inflammatory process is established. Fibroblast growth factor FGF and platelet-derived growth factor PDGF are secreted by the endothelium and foam cells respectively. These growth factors attract smooth muscle cells from the media and stimulate cellular migration and proliferation. With increased accumulation of lipids, macrophages-derived foam cells release free cholesterol into the intima. The cytokine secreted by the macrophages continues to stimulate proliferation of smooth muscle cells. Smooth muscle cells synthesize collagen, leading to the formation of fibrous cap. Smooth muscle cells may also accumulate lipids and become smooth muscle cell derived foam cell. The lipid core is soft due to the accumulation of free cholesterol from the necrotic foam cells. Active infiltration of oxidized LDL, monocytes and T lymphocytes into the intima takes place at the edges, shoulders of the plaque, where the fibrous cap is not well developed. Small feeding blood vessels grow into the plaque.
I hope all of you understand how this oxidized LDL is playing as a real killer. And here only one remedy to prevent the oxidation of LDL to oxidized LDL is the antioxidant. If sufficient amount of antioxidant is present in the subendothelial space, easily we can avoid the oxidation of the LDL. Antioxidant is help to prevent the heart disease. The theory behind this prevention of heart disease by the antioxidant is really because of the prevention of oxidation of LDL to oxidized LDL. Like that, it will help to prevent the atherosclerotic block. So same like always, as pharmacists, we are taking care or we are advising our patient to reduces the LDL and increases the HDL level inside the body, and same way we have to boost the antioxidant in the body also. The intention of this video is that mostly we are talking about the antioxidant and the free radical only because mostly for the beauty purpose and all, but antioxidant or the is a real protector of the body from almost all the lifestyle disease like heart disease, cancer, arthritis, like that almost all the disease in the body, this free radical and the antioxidants are playing very important role. It is very important to understand the free radical and the antioxidant very detailedly. Then only we can suggest a correct, because we all know that vitamin C is antioxidant, vitamin E is antioxidant, grapeseed extract is antioxidant, selenium is antioxidant, and the glutathione is antioxidant, but it is not the same type of antioxidant. When we are recommending the antioxidant to a patient, we have to recommend in the correct way. So next chapter we will discuss more about the free radical and the antioxidants. Thank you for watching my video, and if this information is help you to make a 1-degree change in your professional life, please share with your friends. Thank you.